Well, these kinds of questions are a bit different because now we have two sides of an equal sign. We have things on the left side and things on the right side, and what we're trying to do is to verify that this is already an identity, which means we're trying to verify that the left and right side are equal to each other. So what we do is we take one of those sides, the more complicated part, and we start to change a bit in it until it becomes similar to the other side. For example, I'll start here with this side here that already has the negative sign within, and I'll work out my way around those two. I'll try to simplify this side as much as possible so that it becomes cotan squared times cosine squared, just like how it's written. First, we start just like how we simplify. We start by changing everything to become sines and cosines, and we can change the cotan to become cosine over sine based on the identities. But for this one, we will leave it as it is for the time being. Now, when you look carefully, this is a fraction, and this part is not, and they're subtracted by each other, which means we have to make them have the same denominator. So we will multiply here by sine squared theta up and down so that they have the same denominator. I'll put one big fraction and I'll write the sine squared, the denominator, only once, and in the numerator I'll write the cosine squared theta and then the minus as it is, and then cosine squared times sine squared theta. Alright, then what? Then we split these into, oh actually no, wait. Then when we look carefully, we find that there's this cosine squared available here and there is considered a common factor. What does that mean? It means we can write cosine squared theta outside and open a bracket. If we divided this part by cosine squared, I'm left with 1 and then minus. If I divided this part by cosine squared, I'm left with just the sine squared theta. And still all of this is divided by sine squared theta. Based on the identities, 1 minus sine squared theta is equals to cosine squared theta. So I'll just write instead of that the cosine squared theta, and again over all of this is divided by sine squared. Now cosine over sine is equals to cotan squared theta, and the cosine will be left next to it. Now this is exactly the same as this side over here, so we just proved that these two are equal. We just proved that this is an identity.